Okay, people, this is my third take. I've filmed 20 minutes worth of video so far that hasn't recorded. So, get a little frustrated here. Hopefully, we can do a little bit better job this time. Well, it's nothing I can do better. But, hopefully the computer, M-I-A-M-I, hopefully the computer actually saves this version. Third time's a charm, right? So, Miami, Florida. You have a location. This location is where a seismograph is. And the location exists on Earth, so there's always a time of day. So right now it's 8:05, 8:06 a.m. It literally is. I'm reading it right off the clock. Okay. So these numbers here are times of day. You're going to be given all of this information. You're going to be given the seismograph, actually. You never have to make these. I just like my students to see me make the seismograph, because if you see something get made, it makes more sense. What does it mean? Okay? So you're hanging out in Miami, Florida. You're eating some good Florida food. I don't know what Florida food would be, but you're hanging out in Miami, Florida. Okay? And as you're hanging out in Miami, Florida, you know, maybe you're going to go to the beach. Whoa! What was that? Okay, that was the first wave that showed up, called the P wave. Whoa! What was that? Man, crazy day in Miami, Florida. So that's what a seismograph is. The waves show up. You're always given all of this. Time of day, location, and the actual line. Usually you're given this part right here. Usually it's indicated for you that this is where the P wave showed up. And usually it's indicated to you that this is where the S wave shows up. Okay? Most of the time this is all given to you. Sometimes you've got to say, hey, that's the P wave, because it's first, it's primary. Hey, that's the second wave, secondary wave, S wave. Usually all that's given to you. You definitely need to be able to figure out what time did the P wave show up. This is a time of day. I think you know time of day pretty well, but it does get a tiny bit tricky, because now instead of just hours and minutes, you have to add seconds to it. So what time of day did this show up? 8:05, right? But you've got to get more specific down to the second. Well, that's 0 seconds. Sometimes it's 00 like that. These are broken up by minutes. And just like on our ESRT, where we saw that this was broken up into minutes, 20 seconds, 40 seconds, 60 seconds is a minute. So these little divisions on here mean 20 seconds, 40 seconds, and 60 seconds is the next minute. Sometimes we'll get a little bit more specific and we'll go in between those lines and we'll get crazy and say that that's 10 seconds, and that's 30 seconds, and that's 50 seconds. Okay, but you're just reading time. What time did the S wave show up? Getting a little bit more specific here. 8:06 and some change. 8:06, 20 seconds, 40 seconds. So that's 8:06, 40. Now your time difference is the next thing that you need to be able to figure out. What was the time? And we've used this time difference. We've heard this before on the seismograph or the PS wave chart in our reference table. We figured out by looking at the time difference, you can figure out how far away was the earthquake. What's the distance? This is going to be the next video, is using the time difference to get your distance. Well, right now we're just trying to get your difference. And if you ever try to find a video on this, a different one that teaches you this, they're going to show you how to subtract time. You want to get difference, you just subtract one thing from another thing, and that's your difference. Subtracting time gets tricky. You've got to borrow minutes and seconds, and there's 60 minutes, and it gets tricky. I invented counting. I didn't really invent counting. But counting on a seismograph, I came up with. Okay? I'm sure other people do it because it's the easiest way, but it's not the most common way you're going to find being explained on the YouTube. So here's what I do. I just pick one of these two spots. and I just start counting on my scale. If this is where I'm starting, that would be like the 0, that's the starting line. 20 seconds, 40 seconds, 60 seconds, that's a minute. A minute and 20. What's our time difference? 1 minute and 40 seconds. So that's your time difference. In a separate video, in our series of earthquake learning, you're going to take this number and you're going to figure out our difference. Nope, not our difference. Our distance on our ESRT. So we're going to need this number in the future to figure out how far away was the earthquake. But for right now, we know that Miami, Florida, there was a time difference of 1 minute and 40 seconds. Okay? You're going to practice this with 2 other locations. We always need 3 locations because we're going to do what's called triangulate an earthquake. This is always going to be given to you. So let's say Dallas, Texas. Okay? And it's still, you're always going to ignore like time zones and all that stuff. We're going to cross time zones with this. We're just going to go off the same scale. Time zones are going to be ignored, and that's how it actually is done. So just, you don't have to concern yourself with time zones. Okay? Time scale, 805, 806, 807. Okay? It's the same scale, but I just started at a slightly different spot. Dallas is going to be a little bit further away from the earthquake. So where this showed up at 805, the P wave is going to show up a little bit later than 805. Okay? Because we're just hanging out in Dallas. Whoa. So I was very different in how I drew that. Since it was a further away earthquake, the whoa wasn't as big, right? And since it's a further away earthquake, there's something else you're hopefully noticing. Whoa. Okay? Some of our data is going to look a little bit different because of that. So now you need to figure out 3 things to start. What time did the P wave show up? And what time did the S wave show up? The third thing, which is really going to be the most important thing, is going to be your time difference from there to there. So you start on here and you start counting by 20s, and just remember, if you're in between one of these lines, that's worth 10 seconds to be in between the 2 lines. Okay? So there's a certain amount of time difference, which is different from the time difference here because this was closer to the earthquake. Let's do one more with a town that we know and love. Rome, New York. Not many earthquakes in Rome, New York. So let's say I do 8, 10, 8. Still same time of day. I've just got to do a slightly different scale on here because we're so much further away. The P waves take a longer time to get there. Okay? So when the P waves show up, 8, 10, 8, 11, the P and S waves already showed up at the other one. Whoa. P wave might even be a very little bit of a blip. You know what I mean? There wasn't much of a whoa there because Rome is so far away from the earthquake. And also, you can see how, whoa, that time difference becomes pretty big. The further away that the earthquake is, since the P wave's faster, it's like a race, and it wins the race by more and more the longer away the earthquake is. So you should be able to figure out the 3 pieces of information. What time did the P wave show up? What time did the S wave show up? And what's your time difference? You should be able to continue this scale and figure out, hours, minutes, and seconds from that. If you need to scroll back and forth, those are your 3 seismographs that your questions go with. Part 1 is done.